In this example, I'm going to talk about Lisa. Lisa is a youth. Lisa loves movies and drinking soda, as all youth do. And we have two prices. Movies cost $6, soda costs $3, but we're just going to think in terms of six packs. Okay, so $3 gets you one six-pack of soda, and we're going to assume that Lisa can only consume six packs. We're not going to break up the six packs because that would be a little bit confusing. So here we have a table of all the marginal utilities that Lisa can get, which is good. We've got 0 to 10, 0 to 10. And so what we first are asked to do is to fill in her marginal utility table. Now remember, the marginal utility is just a way of saying the change in utility as you increase your consumption of something by one. So how much does utility go up when you do one additional thing? In the case of movies, buy one additional movie. Watch one additional movie, buy one additional six-pack of soda. So as Lisa goes from 0 to 1, her marginal utility increases by 50. As she goes from 1 to 2, it increases by 38. And we can keep doing this. As she goes from 88 to 21, it increases by 33, 29, 25, 24, 20, 18, 15, 12, and 9. Get that mental math going. And how about soda? Let's see if we can do this one in our heads. 75. And then going up to 117 is going to be a big drop. We're only looking at 42. Then 117, we're going to be looking at 36. Then we're going to be doing, 28. And then we're going to be doing 25. And finally some mercy here. Finally a little bit, nope, no more mercy here. We're going to do, 18? 18, 17, 14, 16, and 15. All right, whew, now we're awake. All right, use a calculator for this. Okay, so we've got our marginal utility table, and what we can see is that, like many examples, her marginal utility tends to decline. Doesn't always have to, but with watching movies and sodas, you can imagine that very reasonably it would. So I'm going to talk through the three different ways that we can calculate somebody's optimal bundle given a budget. So in order to actually do this problem, we need her to actually have a budget in terms of how much money she's going to be able to spend. So let's, for the sake of our own sanity, suppose that Lisa has $24. Okay, $24 is a good amount of money. So let's think about how many different things she could buy for $24. So the way that I would do this is I would start with sort of the extreme cases. What if she spends all her money on movies? What if she spends all her money on soda? So if she spends all her money on movies, how many movies can she buy? For $24, she can go see 4 movies. So she could buy 4 movies and 0 sodas. All right, now what if she sees 3 movies? If she sees 3 movies, that costs $18, and that leaves her 6, which means she can buy 2 sodas. And if she goes to see 2 movies, that means she spent $12, and that means she can get 4 sodas. If she sees 1 movie, you can see the pattern here, and she can also spend all of her money on sodas. All right, so these are all her optimal of all the possible combinations she could choose from. Essentially what we've done is we've kind of plotted out her budget line in terms of what is the trade-off between movies and soda. And so she's going to try to spend all of her money because in all cases, consuming either thing makes her utility go up. The question is just which one's going to make her the most happy. So if she consumes 4 movies and 0 sodas, then what is her utility? Her utility is going to be read by going to this chart and seeing that her total utility is 150. And then she has no utility from the soda. You can actually see it right here, but we also know that that's 0. Now let's say she consumes 3 movies. In that case, she gets 121 from the movies, and she gets 117. So 121 plus 117, that's 238. Okay, so that's clearly better for her. Now, what if she does 2 movies and 4 sodas? Well, then she gets 88 and 181. 88 plus 181. So if she does that, that's 269. Even better. Now, what if she does 1 movie and 6 sodas? So she's really got a lot of sugar. She gets 50 from the movies. She gets $2.25 from the sodas. Even better. And what if she does all sodas? That's $2.60. All right. So we're going to pick the thing that makes her the most happy, which is this one. We're going to spend all her money. So $2.75 is the most amount of joy she can get out of ways to spend all of her money. Great. So now let's do the other methods, the walk down and the marginal utility over marginal price. So I've copied here the marginal utilities so we don't have to rewrite them and scroll back and forth. And we're going to think about how much additional utility she gets per $6 per dollar she spends on movies and for soda. So now we're going to get into fraction land. So I'm going to pop out a calculator. Pop the calculator. All right. And so let's look at her marginal utility per dollar for her first movie. So that's 50 divided by 6. And so that's going to be 8.33. Then 38 divided by 6 is 6.33. 33 divided by 6 is 5.5. 29 divided by 6 is 4.833. You get the idea here, but we're going to keep doing it. Feel free to skip ahead. This is getting boring. 21 divided by 6 is going to be 3.5. This is going to be 3, 2.5, 2, and 1.5. All right. Now let's look at the other side of things. So things are going to be a little bit more divisible by 3. So we're going to take 25, 17, 12, 28 divided by 3 is going to be 9.3. 25 divided by 3 is going to be 8.3, 6.3, 6, 5.7, 5.3, and 5. All right, so now that we've got these marginal utility per dollars worked out, we can use the walk down method to figure out what is the best way to spend all of our money. So looking at these choices, we can see that right off the bat, we're going to want to spend our initial money on soda because it's going to give us the best bang for our buck, or it's going to give us the most value, most utility per dollar we spend, really until we get down to the fifth one, in which case then we're going to jump over here, and then we're going to swing back over here, and then we're going to keep going, right? I've done a little bit of rounding here. I should make this clear. This is actually 3, 3, 3, 3, 3, 3, 3, 3. So those are going to actually be the same. So let's work that out. So we're going to do this one, because it's 17, then 12, then 9.3. Now here it's actually the same, but we've got money. We can get both. Great. Let's check in on how we're doing on our budget. So here I've spent $6, and here I spent 1, 2, 3, 4, 5 times 3 is 15. So I'm down to up to $21. Now remember, Lisa's got $24 total. So this is 21, which means she has $3 left. So she would, ideally, she would love to buy both because this is tied between the two, 6.33 and 6.33, but she can't afford the movies. So she's just going to buy the soda. So in this case, we're going to give her the soda, and now she's out of money. She spent $6 on movies, she spent $18 on soda, and so she's good. So her optimal consumption bundle is 1 movie and 6 sodas. And what's great is that we have done the same thing and found the same answer as we did over here, only we didn't have to do quite as much math. Though if we're honest, we still had to do quite a bit of math. Now the other thing we could do is we could do the marginal utility equals marginal price method. This can be a way kind of to speed things up, but I usually like to double check just to make sure, because sometimes we'll get kind of 2 places where things are the same. So for example, what I'm going to do is I'm going to consume up to the point where the marginal utility is equal per dollar is equal across the 2 goods. So the other method we can do is we can also look at the marginal utility per dollar spent, and we can set those 2 things equal with the idea that when we're at that place where we're indifferent, we've kind of got the right balance between the 2. So there's 2 places where I can see that to be the case. I can see that here, and I can see that here and here. And those are really the only places. So let's say that I consume right here. So in that case, I bought 1 movie and 5 sodas. At that point, I have spent 6 times 1 plus 3 times 5, which is $21. And so I've kind of got to stop there, but I've got $3 more. So I'm going to spend that remaining on my last soda. So again, the same combination as before. The other way you could think about it is you could say, well, let's say we don't go to that one. We want to compare the $6 ones. That's another equilibrium point where the two things are equal. And if we do that, then I spent 2 times 6, and I've spent 1 times 6, and so that's 12 plus, that's 6 times 3 times 6 plus 18. So I've broken the bank, so I have to get rid of something, and so I'm going to get rid of one more movie. So that's the other way we can get and receive the same conclusion. Now let's suppose that the price of movies has fallen to $3 a movie. So in this case, Lisa is extremely happy because now she gets to buy more stuff. So her soda situation has not changed at all, right? So we're going to just copy down these numbers. So in this case, we're going to have, what is that, 25, 17, 12, 9.33, 8.33, 6.336, 5.67, 5.33, and 5. Nothing's changed there. All right, and now her marginal utility per dollar for movies has effectively doubled. So it's basically going to be all these things times 2, because basically what I'm doing is I'm taking 50 and dividing it by 3, which is what's going to give me 16.7, then 12.7, then 11, then 29 divided by 3 is going to be 9.7, 5, 7, nope, that's not 5, sorry, that's 8.3, 7, 6, 5, 4, and 3. Okay, so again, we can do the same thing. My preferred method is just stepping it down. So that's what I'm going to do. I'm going to have her spend her first dollar here, her second dollar here, her third dollar here, her fourth dollar here, not dollar, her fourth purchase here. And remember, she's still got $24. So we can keep going for a while. Here, 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 and here. Let's check in where she is here. So now she's consumed 5 times 3 for movies, which is $15, and 5 times 3, which is $15. She's consumed too much. We got to walk it back. So let's get rid of, we got to get rid of both. So let's get rid of this one and this one. And now we're good. So now she's consumed 12 plus 12, so that's $24. So that's going to be her optimal bundle, is 4 movies and 4 sodas. Now what's also cool here is now we have a situation where we know what her consumption is in terms of movies at a price of 6 and what her movie consumption is at a price of 3. We could actually plot out her demand curve because we know that when the price is $6, she consumes 1 movie. And we know that when the price is $3, she consumes 4 movies. Essentially, this is creating a demand curve. And that's the intuition here, is that if we were able to model out what people's optimal decisions are at various prices, that is how we know what a demand curve looks like. And we can see that as the prices have fallen, Lisa consumes more because essentially that movie becomes a better deal. It gives her more joy. And so in a way, this aspect, this process of kind of doing all this seems a little bit tedious, but it's actually the intuition, it's kind of the building blocks of what ultimately is an individual demand curve, which we've been playing with all semester. So I think that's kind of neat.